Hello, everybody. Welcome to the midterm one review. So today, first, I'm going to go through like kind of the main bullet points of what we've gone over, what we learned, so you kind of have a list of what we've covered, and then I'm also going to do some sample problems. Okay, so let's see, what did we cover? So first, section 1.1, that was real numbers. And in it, we covered properties. So that was commutativity, associativity, and my favorite, distributivity. And we also did some things with interval notation. And that includes things with intersection and union, right? So chapter 1, or sorry, section 1.1, really short. So 1.2, let's see, that was exponents and radicals. And in that we did like basic simplification. And also we talked about fractional powers. So like x to the 2/3, for example. Section 1.3, let's see. Oops. That was polynomials and factoring. And let's see, we had the AC method, right? So the guess and check method. We had the special factoring formulas, which I will abbreviate as FF. And then we also had factoring by grouping. Good idea to know all of those techniques. That was followed by 1.4 was rational expressions. So polynomial over polynomial, right? But within that section, we also talked about compound fractions and rationalizing the denominator, or at least in more generality. 1.6 was complex numbers, which kind of was very short, just covered sort of the basics. And then 1.5 was meaty. That was solving equations. And so let's see, what were the different kinds? We had like basic linear ones. We had quadratics. And within quadratics, we used the quadratic formula. Right, good to know that one. We also did absolute values. Fractional equations, equations with a radical. And then we also did equations with multiple variables. Which, again, sound bad, but are actually fairly straightforward. And then probably the hardest section so far is 1.7 is modeling word problems. And so we did simple interest, mixture, time for a job, and lastly, but not least, distance, rate, and time problems. And then 1.8, which was covered just very recently, was on inequalities. And the main focus for that are like regular, standard, basic linear ones, and then quadratic, fractional, so with rational expressions, and absolute value. Okay, so I wrote down this list and I'm giving it to you as kind of like, sort of like a short list for kind of the things that you are responsible for on the midterm. It is kind of a longer list, but I hope it at least gives some sort of bird's eye view of what we've covered so far. So let's go ahead and let's take a look at some practice problems. And I'm going to do some word problems because I think word problems are going to be the hardest thing on the midterm, because word problems are very tricky. Honestly, even for me, I have trouble with them sometimes. They're not easy to decipher. So let's just go over and look at some examples. So I'm just going to pull them from the practice midterm. So let's do this. Let's do, yes. Okay. Can I make it bigger? Ah. No, okay, well, this is a coin problem, right? So my swear jar has a total of $5.50. In it are only nickels, quarters, and dimes, but there are twice as many dimes as quarters and 3 times as many nickels as dimes. And I want to know how many quarters are in the jar. So this is kind of similar to a homework problem that we had. So let's go ahead and write down what we know. So we know that total is $5.50, right? We know that there are twice as many dimes as quarters. So however many quarters there are, we know there are too many of that, or sorry, gosh. If we have some number of quarters, we know that 2 times that number is going to be the number of dimes, right? Because there's twice as many dimes as there are quarters. And then there are 3 times as many nickels as dimes, which means that depending on how many dimes we have, we multiply that by 3, we get the number of nickels. So here we've got Q is quarters, D dimes, and N nickels, right? And so since we know the total is going to be $5.50, we can say that, so 25 cents times however many number of quarters plus 10 cents times however many number of dimes plus 5 cents times however many nickels is going to be $5.50. And so now what we're going to do is we're going to need to sub some things in. We want to know how many quarters there are, so I'm going to leave Q as it is. And then if I divide, taking this equation right here, if I divide both sides by 2, I get Q equals D over 2. So I'm going to write this as, or sorry, we don't need to do that. We can just take D as it is right here, like that. And we can sub in 2Q right there. And then N is slightly trickier, but we're going to use this equation here, right? And we know D is equal to 2Q, so I'm going to put 3 times 2Q equals N, and that will give us that 6Q equals N, right? So there are 6 times as many nickels as there are quarters, is what this is saying. And so we can take this here, and we can sub it in right there. So this then becomes 0.05 times 6 times Q, and that's all equal to 550. Excellent. Okay. So then let's go ahead and simplify a bit. So we still have 0.25 Q plus 0.20, because 2 times 0.1 times Q plus, let's see, 5 times 6, that's 30. This will be, oops, 0.3 Q, right? Then if we add these up together, we get 0.55q equals 5.50, right? So I just combined all these terms together. And then I'm going to divide on both sides by 0.55. And I should get q equals, these cancel. And then if we do this division, I believe we will find, so I can move the decimal over 2 places. And then this should give me 10. Yes. So we know that there are 10 quarters. Very good. Excellent. So that is how you would do a coin problem like this. Okay, let's look at another problem. Let's see. Let's do, oops. Okay. So you and your friend decide to start running together. Your apartments are 10 miles away from each other. So let's say that this is, let's say my apartment. And then this is friend apartment. And we know they're 10 miles away. All right, and so we're gonna run. We're gonna each start at our apartments and we're gonna run and meet in the middle somewhere. Okay? However, we know that my friend runs 50% faster. And so when we meet half an hour later, we want to know how fast are each of us going. All right, so I'm not going to lie. This is quite a tricky word problem. This is too hard to put on like an actual midterm. I wouldn't ask something quite this difficult from you. But let's go ahead and take a look at it because it does have some good things to talk about. So let's go ahead and write down what we know. So there's a bunch of different things. I'm going to do, like T sub m for my time, D sub m for my distance, and R sub m for my rate. So these are mine. And then I'm going to do sub f, where that's from friend. Okay, there's a lot of variables, but let's see if we can't put them into some equations. So because it's a distance, rate, and time problem, distance equals rate times time. So we already know right off the bat that no matter what, we have these two equalities. Right, all right, now let's go look up here and see what else we can extract out of this. So we know that we are both running together a distance of 10 miles, right? Because, you know, we're going to meet somewhere in the middle. And so together, both of our distances are going to be 10 miles. So we know that this distance plus this distance is 10 miles, right? We also know that the total time was an hour and a half. So we know that, and if we start at the same point, we're going to have the same time passing. So we need 1.5 hours is equal to my time. It's also equal to friend's time. Okay, cool. I think this actually gives us a good starting point. So if we go ahead and look at this equation right here, I'm gonna sub in for dm, I'm gonna put these two in. And for df, I'm gonna put these two in. And actually, I did forget to write down one more piece of information we can extract from this problem. It says, our friend is running 50% faster than me. So if we look at that in equation form, that means that the friend is my speed. So where R is rate, speed, and 50% faster means the speed is 150% of mine. So it'll look like this. If it were, say, like 20% slower, that'd be 100 minus 20 is 80, so that'd be 0.8 in front instead, if it were like 20% slower. But 50% faster is 100% plus 50%, so 1.5. All right, so now what I'm gonna do is I'm gonna take, this equation here that I was talking about earlier. I'm gonna sub that in. And so I'm gonna get my time times my rate plus friend time times friend rate. And we know that that's gonna be equal to, right here, 10 miles. Now we know what TM and TF are. It's right here. So I can go ahead and sub 1.5 times RM plus 1.5 times RF equals 10 miles. And then I'm going to go ahead and right here, I'm going to sub this in right here from this equation. So now I'm going to get 1.5 RM. Make sure that's underneath. And then plus 1.5, not RF, we're going to replace that. And it's going to be 1.5 RM equals 10 miles. Okay, now let's do some simplification. So we still have 1.5 here. And then 1.5 times 1.5, I believe is, what is that? Sorry, give me just one sec. Having a brain fart. Yes, 2.25, I think is what you'll find if you do the multiplication out. RM equals 10 miles. And then we add these together, we get 3.75 RM equals 10. And then divide on both sides, we get the rate is going to be 10 over 3.75 miles per hour. And so for word problems like this, I'm not going to bother simplifying that. So I know that my rate is whatever that number is. And so then my friend's rate is going to be 1.5 times that from up here. So then RF is 1.5 times 10 over 3.75 miles per hour. And this I would consider complete answers. I'm not going to bother trying to do the arithmetic for this. I believe that you can multiply and divide numbers. I don't need to see you try to slog through something like that. But yeah, that's how I would do this problem. Again, this is more involved than most, and I wouldn't ask something this difficult on a midterm. But it has some important key concepts like understanding how to do percentage differences like this, as well as just looking at extracting information from a word problem. Cool. All right. Good luck with your studying, and I hope to see you in office hours.